All right, good morning, everyone. We're just going to give everyone just another minute or two to join, and then we'll kick it off. Thanks. All right, in the interest of time, we'll go ahead and get started. I do see that we have a fair number of folks attending this morning, so I want to just start off by thanking everyone for joining this morning and joining us for this webinar, Designing Control Rooms to Support High Penetrations of Variable Renewable Energy. This webinar is presented by the Global Power System Transformation Consortium and by the Pillar 2 lead organization, the National Renewable Energy Laboratory. So thank you again for joining us this morning. I am going to go through a few housekeeping and WebEx tips. WebEx is the platform we are hosting this webinar on. You can see here there's just a couple recommendations. So I believe everyone is automatically muted and does not have camera enabled. If you have questions, we will have a question and answer period at the end of our presentation today. So please feel free to, just hang on to your questions until then. But if you want to send them in, you can send them into, we have two methods that you can send them in. We have a chat box. If you are sending it via chat, please be sure to select all panelists when you are sending it for the to option. That way we can all see the questions that come in. We also have a Q&A panel. So either way, we'll be monitoring both of them, but you can also send it into the Q&A panel. So chat or Q&A, either way works. And like I said, we will address all questions at the end in a moderated Q&A session. You do have a couple options for changing your layout for how you are viewing the screen. So you can have a grid, your grid option, your stage option, or your focus option. So those are controlled on your end. So if you're not a fan of how it's laid out right now, just try and adjust your layout and you can sort of have a couple options there. And finally, if you're having any audio issues, I recommend checking your audio inputs and outputs. Just make sure you don't have it connected to any Bluetooths that you're not aware of, things of that nature. I also recommend if you're listening by computer, you can try dialing in by phone. WebEx does have an option to call you or have you dial in. Or if you're listening by phone, try tuning in by computer audio. So basically, if you're having any audio issues, I recommend just swapping out the way that you're listening and try the alternative method. So our agenda today, and before I move on, we are recording this webinar, so it will be recorded. It will be able to be found on the Global Power System Transformation Consortium website after it's concluded, so we will have a recording available. So our agenda today, we are planning to have this webinar last between an hour and 75 minutes, just depending on time. It will likely run about 75 minutes in total. My name is Isabel. I'm doing the welcome right now. We will have an overview of what the G-PST Consortium is, and then we'll move into the meat of our presentation, where we will be spotlighting some upgrades to the Java-Bali grid control room, we will be hearing about lessons on developing country control rooms and on developing control rooms of the future, as well as how to design control rooms to support high penetrations of variable renewable energy. And as I mentioned, our remaining time will be used for a Q&A session at the end. So our speakers here today, as I mentioned, my name is Isabel. I am your host. So I will be sort of progressing our slides and driving us today and just helping out in the chat and Q&A. We have Sadie Cox from NREL. She is the director of the G-PST Interim Secretariat. She will be providing the overview of the G-PST Consortium. And then we have our presenters today, Ivi Haryadi from PLN Indonesia, who is the head of their Center of Excellence, who will be providing those Java-Bali control room upgrade updates. We have Adrian Kelly from EPRI, the Electrical Power Research Institute, who is the Senior Technical Leader of Grid Operations and Planning, Power Delivery and Utilization. And we have Hongmin Zhang from NREL, who is a Chief Energy System Modeling Engineer here, who will share a little bit more about those best practices for designing with high penetrations of VRE in mind. So with that said, I will hand it over to Sadie Cox, who will give us an overview of G-PST. Hi, Sadie.
Hi, great. Thanks so much, Isabel. Can you hear me?
Yep, we can hear you.
All right, great. So hello, everyone. It's great to have so many folks on the webinar today, and thank you so much for joining. As Isabel mentioned, my name is Sadie Cox, and I'm the director for the G-PST Interim Secretariat and an analyst at the National Renewable Energy Laboratory. And so for those who might not be, or who might be new to the G-PST, I just wanted to provide a brief overview of the consortium before we dive into the more technical webinar content today. So the G-PST is a new initiative that we recently established together with many partners around the world with a really targeted focus on support and collaboration with system operators to research and implement cutting-edge technologies and solutions required to bring very high levels of renewable energy and other complementary technologies onto the grid. So to really set the research vision of the G-PST, we've been working with our group of founding system operators, or FSOs, at the CEO level. And this includes AEMO in Australia, National Grid in the UK, EIR Grid in Ireland, Energinet in Denmark, California ISO, and ERCOT. And this is really a group of system operators that's leading the world in terms of current VRE penetration levels. So these FSOs, together with our technical institute partners, are championing research activities of the consortium, and they've been defining a set of common research priorities, which can then inform really critical R&D investments at the national level. In addition to the FSOs, we also have a core team of world-leading technical institutions, which you can see on this slide, so I won't name all of them, but they're covering many regions of the world, and they've come together to really define the direction of the consortium and to lead on specific topical pillars and regional activities. And in addition to the core team and FSOs, we're also partnering with 10 developing country system operators to support them in advancing power system transformation. And many of them will also be serving as leaders for peer learning in particular regions. And we have official partners listed here, which include system operators in India, Indonesia, Vietnam, South Africa, and Peru. And so today we'll of course be hearing from our partners at PLN on the work that they're doing on their control room upgrade for the Java-Bali grid. So this group of partners, with this group of partners, we're supporting power system transformation globally through our 5 action pillars. And so pillar 1 is coordinated by ESIG, and this is where we're bringing together our founding system operators to both develop a high-level research agenda, as I mentioned, on the most forward-looking research areas to support very high levels of renewables on the grid. And then that information can be used by many national governments to inform critical research investments. And then pillar 2 is where the core team and FSOs are partnering with emerging and developing country system operators to provide deep technical support through fellowships and targeted technical assistance on advanced operational and engineering solutions, as well as broader peer learning at the regional and global level. And so our webinar today is focused on pillar 2 support. And again, we'll be hearing from PLN on the work that we're doing together. And then pillar 3 is coordinated by Imperial College in London, and it's focused on improving and applying cutting-edge educational materials and courses at the university level, as well as upskilling the current system operator workforce with continuing education, Pillar 4 is coordinated by IEEE and is focused on supporting countries on technology standards, certification, and testing to enable higher levels of renewable integration, as well as complementary technologies, and really localizing technologies to very unique contexts. And then Pillar 5 is coordinated by VTT in Finland and is focused on collecting, improving, and disseminating best-in-class open data and tools to support system operators with various types of key analyses to enable grid integration. And so that's the G-PST kind of in a nutshell. And on the next slide, I'll talk a little bit about some of the opportunities to continue to engage with the G-PST as we go forward. So we'll be continuing to have our webinar series. We're planning to have 2 webinars a month for at least the next year and following that as well. So in March, we'll have a Pillar 1 webinar on grid forming inverters, and then we'll have a Pillar 3 webinar that's again on that workforce development topic, but at the kind of the deeper subtopic of that is still to be defined. We're also very happy to have you all join our network, our G-PST network, to receive webinar invitations. We're also going to be launching a bi-monthly newsletter in March, and you'll be able to receive updates on kind of the status of the G-PST and our various activities. We're also really happy to have you engage with some regional peer learning networks that we're setting up. So you can submit interest in either of these peer learning networks or in some pillar groups that we're also establishing through our website. We have the link listed there. We're also glad to have you reach out if you're interested in receiving any kind of light touch technical assistance through Pillar 2 of the G-PST. We're exploring opportunities for deeper collaboration as well. And then, yeah, just always happy to have you all reach out if you have any questions or feedback on the G-PST. And so we have our email address listed here. So that's it for me. Thank you all so much, and we'll dive into the technical content now.
Thank you, Sadie. So our first presenter is Evie Haryadi from PLN Indonesia, who will walk us through those Java-Bali upgrades. So take it away, Evie. Evie, I think you might still be muted.
Thank you.
There we go. No problem. Thanks.
Good morning, everybody. I'm Haryadi from PLN Indonesia. In this morning, I would like to share some information from our organization about our plan for implementing the new advanced control center. This next. This is our building of control center in Jakarta, Indonesia. Next. This is the background that we are facing now in Indonesia. Now we have the existing control center that has been operating from 2005, and will be not supporting again. We obsolete in correlated to hardware and also the operating system by the end of 2021. We are now using the operating system, the Centralized 10, and also the hardware of Oracle Spark. Because of this operating system of Centralized 10 and also the hardware Oracle Spark has been obsolete, especially for the hardware one. Now the Spectrum Power System 4.6 also don't have any support from Siemens, because they just only support now based on the Spectrum Power set. For mitigation this problem now, we're preparing for buying some workstation in the market before they're obsolete by the end of 2021. Because we still need this operate till we build the new control center. Maybe will be finished around 2023. Next. Another problem is we also has already maximum capability of this software of the Spectrum 4.6. in Indonesia, because we still the growing country, our electricity growth is still around 4 or 5% a year. Start from 5 years ago, we have a project of 35 gigawatt program, and of course this is including generation and also transmission project that will be need some adding data and updating existing application if we install all this project in the system. Now, this our SCADA system, the capacity of the master station has been increased more than 2 times of the maximum design, and has caused a degradation in the performance of the master station. Next. Our goal for building the new control center is first, we want to make a simplification of our existing control center to become just only one main control center and one disaster control center to optimize the control and speed up our recovery system. Another goal is how we support the future challenge technology. One is because the growth of Java-Bali electrical power system that will be still around 4 or 5% in the next 10 or 20 years. And also the entry of renewable energy generators, storage system, and possible HVDC device in our system. Another is probability we also change in regulation and also the transaction model in our electricity structure. Another is the industrial revolution 4.0 or also disruptive technology. The new control center must be answer this kind of challenge. Next. This our existing control center that we have one EMS control center is 500 kV control center, and we have the hierarchy control center with 5 regional 150 kV switching control center. The EMS just only in 500 kV in one place, and the dispatcher using also have some tasks for switching for 500 kV. All the RTU in the field for 500 kV directly connected to this 500 kV control center. But for 150 kV is in every region is effectively connected in every 150 kV control center. We are using multi-site database system. But the problem is if something happen in one control center, let's say for 500 kV control center have some problem there, it means we lost the EMS system, and this 150 kV cannot do the EMS one. And also if 150 kV control center lost the data, it means not the bus, but totally the control center. It means the other control center cannot handle this lost control center. We want to change this, become only one main control center in maybe in Jakarta, in the same place with our 500 kV control center or EMS control center. Another is there is one disaster control recovery control center in another place. Let's say for this in Surabaya or another place. We want to connect it directly the RTU for to this control center. It means the RTU have a 2 master, and if something happen in this RTU, it means another control center can take control of one control center that cannot handle this. It means all 150 kV control center all move to only one place. and it will be there is some transition problem here. Next. Another is we want this master station also support the PRA forecasting, AGC implementation, and also integrated to our production optimization. And also we have also the operator training simulation, and we want to have also this advanced operator training simulation. Another is we want to have some support in our advanced power system analysis. Now we just only use the static tools for our dispatcher. We won't have this dynamic security assessment in our system. And we know you also have some wide area monitoring system, but still not integrated with our system now. We also want to integrate this all in our system. Another is because of now we just only have one single buyer that also be in our institution. Now all of the transaction based on this kind of single buyer system. There is some possibility because now start from now is still it may be there is some oversupply condition in the next 10 or in the next 5 or 10 years. Maybe the market structure will be changed also because of penetrating of renewable energy. We want also have this kind of advanced market-based power transaction model in our new system in control center. Next. It's okay. This is one example of our WAMs based on based on the what's called facial measurement, and also we have the EMS, but still there is no integrating between these two. We want this WAM improve by this control center, the new control center, to integrate to our EMS, the existing EMS, or the new EMS. And next. Okay. Next slide, please. Okay. Now we also have this condition where we still using that I said before that we are only using the static tool in our system. We want because the new penetration of renewable in the futures and also some constraint in our system because now we grow very fast. In some problem happen like in transmission construction. It make a lot of constraint in our power system. We need also the dynamic analysis in our system to make dispatcher a good decision support system. We need this to have a good visualization for them to countermeasure all the problem in the system. Next. Another project that must be finishing is related to our LFC and the AGC. In our system now, because of we just only have old technology of generators that not support some AGC implementation, we are using the LFC system in our system. The new generation not use the LFC, they are equipped by the AGC system. We want to integrate this, the LFC system and also the AGC system, the new generation that equipped by the AGC system to one system integrated in our power system. We also want to have the optimization, because now we are using the economic dispatch, just only the offline one. We want to integrate also this economic dispatch to become the online economic dispatch. This is the challenge of the new control center that we want. And also now we are using the weather forecast just only for offline forecasting. We need this also can be integrated into the new control center that can make intraday intraday planning. Now we are just using 1 day ahead planning and start doing intraday planning, because it's a lot of what you call a lot of weather's condition, especially now in COVID condition. We have a big error in forecasting. One is because of the change of individual activity or the society activity, and also the other is the weather one. This weather forecast is very, very important for us for start from now, especially if the new renewable comes to our system. And we want this weather forecast integrated also in on real-time control system. Next. This is the progress and also maybe the potential collaboration between PLN and the G-PST. We have some knowledge sharing from G-PST. Thank you very much for Sandy and Khalid for this sharing knowledge. And until now, we have finalized a Thor document for international consulting firm. And now we are cooperating with, because we are a unit, we also cooperating with our headquarters, the Strategy Procurement Division at PLN headquarters, for document and procurement process. And another potential collaboration with G-PST, maybe we will make some market sounding, especially for potential control center vendor that can be answer that challenge that I explained before. Another is besides SCADA EMS technology, we are also have some difficulty in related to the RTU communication link and the forecasting on renewable, especially related to meteorology like weathers and also another issue. And another issue is related in transition process of this implementing the advanced control center from the existing control center to become the new control center, especially in human resource and also in another technical issue. Next. I think that's all for from me. Thank you very much for your attention.
Thank you so much. We'll go ahead, and that was a great presentation. We'll go ahead and move to Mr. Adrian Kelly from the Electric Power Research Institute, who will walk us through his presentation.
Thank you. Hopefully you can hear me okay, Isabel, and my video is clear. Let's close this in. So I'm speaking to you today from Dublin in Ireland. I think I got the best deal. I think it's might be late in the evening in Indonesia and early in the morning in Colorado. So thank you for scheduling around that. So I'm going to talk about some of the lessons learned that we have encountered when we have been talking to our members, our EPRI members, on developing future control rooms. You can go to the next slide. This is a very, very broad topic. We could spend days or multiple days talking through this. But I'm going to try and focus on a couple of key areas here today. The trends that we see in future control room design, data modeling, software visualization applications, and then finally hardware and decision support. And I will touch on just briefly, with the proviso that there's a lot more information that we could go into, and I'm happy to go into that if you'd like to get in touch with me offline. So we, as in EPRI, are the world's leading research institute. We've got 450 members, utility members from all over the world on all continents. So we have connections to essentially the control centers in many countries and regions. So what we've been hearing when we've talked to the folks that we connect with, the trends that we're hearing about are usually associated with things like automation of manual tasks on the controller in the control center. So AGC was mentioned by Evie. It's a good example, but also automation of reporting, logging, those types of things. We're seeing them being taken away from operators because this is seen as a waste of their time. We're also seeing digitalization or going to paper-free environments, artificial intelligence or mostly data analytics on data applications in the control center. Of course, cyber physical resilience is front and center. So we're seeing cyber secure design, so security built into designs of systems. Data platforms, and then obviously this move towards variable generation, variable demand. So improvements, trying to improve in forecasting of load and forecasting in weather. The bottom right corner there, you'll see Operations Readiness Center. So this is a kind of an interesting one. Many of our utilities now are thinking about setting their dispatcher training simulator, their training environment as almost like a shadow operations center. So it can be used to test new applications in early stage development for user acceptance tests. It can be used for upgrading the system and testing on the live system, and just things that are not needed in the control center that can be taken to a different environment, a sandbox environment. So that's important. I saw that mentioned on Evie's slide. So this is something that's moving the industry forward, I think, here. But these are just some broad trends. I'll touch on some of them in the next couple of slides here. You can move it on as well. So how would we think about it? So you guys are going in PLN are going down the route of consolidating your control center from 5 into 1. Which is a very good approach to this, and will help you to be resilient and robust in the future. We have been working with, so some of our members have asked us to develop future roadmaps for the control center of the future, which I think you guys might be looking for as well. This is a high level approach we've been taking, but it can be applied to any system. So in Europe or South America or Asia or the US, North America. What you want to do essentially is to look at your future scenario. So do you in Indonesia foresee huge growth in, for example, solar, offshore wind, battery energy storage, demand data centers? Look at that and try to figure out what are the needs based on your future scenario. So we emphasize don't start with the tools. So don't start with I need a tool, be it WAMS or DSA or whatever, and try and find the need. Find the need first. So look at your future scenario, your future market. Where is it heading? Where's it going to be in 5 years or 10 years? And it's easier then to map technologies and tools to those future needs. And that's what we've been working on. That's proven to be an effective methodology for developing a roadmap. And also looking at the trends. So all of these technologies do have, trends of development. So they're going to advance year to year to year due to improved algorithms or improved technology. So WAMS will improve, dynamic security assessment will improve, OPF may improve. So you need to kind of go, right, in 2021, our system is here, the technology is here. What's it going to be like in 2025, in 2030, in 2035? So that you can map out, okay, what's our development cycles for these technologies. So once you have firstly the future needs and the trends for your future technology, you can map these up and start to integrate them into your control center. We also recommend role and task analysis. So look at what your operators are doing on their system right now. Is this applicable for the future system? Can it be changed or modified? Or are there other applications needed in the control room, like renewable resource control, market operation, cybersecurity, physical asset health monitoring, security? Those types of functions could be potentially integrated into real-time control. Lastly, you're talking about project implementation plan, visualization. You know, VR experiences can come from your designs, but they're the final steps in the pathway. This is a high-level roadmap. Feel free to look at it and let me know if you want some more details in it. Again, and we are applying this in EirGrid in Ireland, in Tenet in Netherlands and Germany, and in other locations all over the world. So next slide. This is just a kind of example of how you would get from your future scenario to the risk assessment. So here's where you would, this is what I was saying at the start, your first step should be look at your future energy scenarios. What are your system drivers? What are the needs on your system? And then try and see what your issues or risks are going to be. So you can see that second box on the right, you've got voltage issues, fast ramping, congestion, weather events, low inertia, weak systems. These can be all issues and they can be risk assessed. So you can then ask your, you can then see which of these challenges are going to be very impactful and which are going to be more probably likely to occur. Yeah, this is just a framework or methodology for how you would start with your future scenarios and get to what your risk assessment is to see what the most urgent needs are for your future control center. Next slide. Yeah, you can move on the animation. So what somebody asked is, or what was a kind of a need here was to think about, if you're in a very good position in PLN now, you know, you're at the stage you need a new system, so you can rip up the old system and start from scratch, almost blank sheet of paper. I would say a lot of the utilities around the world would be very envious of this position for you guys, because most of the time they're trying to customize or retrofit existing systems that have been there for many years. They're legacy, they're suboptimally designed, all of this, and there's multiple systems all hanging off each other. You guys are in a good position. You're starting from scratch, and that gives a good opportunity to think about how to set up your system for future operations. A key one here, I think, is around alarming. So if you take a lot of alarms via your SCADA back to your operators, it's likely that they're getting a lot of alarms being flooded in all of the time, especially when there's events happening on your system. And I'm not certain about your processes, but in the 95% of utilities around the world, the alarm system is not very well designed or not very well functional. So there's text issues. Alarms aren't prioritized correctly, and there is a kind of alarm floods for events instead of showing concise information on the system. So what we recommend if you're starting from scratch is to build your alarm system to be useful, both for the operator and also for future algorithms, data analysis, AI, artificial intelligence, that type of thing. And machine learning. So you need to structure your alarm data so that the operator gets really clear instructions from them. They're not searching for lots of lots of text to find answers. They get really clear answers. And then structure the alarm text so that it can be analyzed, right? So if you see here, the table on the right is an example. So an unstructured text string might be alpha station 500 kV TX1 oil. This is text. It's very difficult for algorithms to analyze what's in that, unless you build in rules and interpretation rules. So what we propose is to try and break this down, make this unstructured strings into structured data. So break it into station, to asset class, to device, to voltage level, and then status. So that then later on, when you're querying your system and trying to find what's wrong with your system, or if there's patterns you can identify, this is how you do it. You want to find out what your transform loadings are. You can query it off the device. You want to find out where your most alarms are, you can query it off voltage levels, right? So making unstructured information into structured information is very, very important, and you're in a good position, so I'd recommend to do that. We also recommend prioritizing your alarms, so having, making sure alarms are actionable, so high priority alarms need to be acted on straight away. Within 1 minute, the operator needs to act. Less priorities could be priority 2, should be a lower color, maybe needs 30 minutes, 1 hour. And then less priorities again are, 2 hours or beyond, things that can wait on the system. So it's a good opportunity to rationalize your alarm system in this way. Next slide as well. Yeah, this is just a summary of it. So you can break down your alarm system into alarms, situation awareness events, and then pass-through events, which we have here. EPRI have developed this over many years. So alarms are only actionable information. Situation awareness events are things that aren't actionable but are useful to the operator's situation awareness. And then pass-through events are things that don't need to be in the control center. They can be moved to IT or asset management or protection or other functions within your company. They don't need to be disturbing your operator. So break your alarm system down into these 3 buckets, and you'll have a very effective control modes. And it will really help. Your operators will thank you for doing this for them because it will reduce their overload. So we recommend an alarm documentation rationalization process. Next. Architecture. So I know Hong Ming is going to cover this in quite a bit of detail. So there's a certain move now to move to an architecture, application and data architecture from kind of the existing Purdue hierarchical model of architecture to something that's more functional for the future control room. We see it here on the left and the right. So applications outside the control room linked only via data exchange, push and pull kind of systems, via the control center applications, which have EMS, MMS, market management system, your WAM system are all in the control center block or bucket. These are connected via SCADA, IEC protocol, standard links to your field assets. And then there's like an API layer over on the right, which connects with your data and outputs that to other systems, or other stakeholders are allowed to access this. This is kind of an example of a modular structure. So you can essentially modularize your system, and it's vendor agnostic. You don't get tied into one vendor for an application. You should be able to plug and play multi-vendor approaches into your control center applications and your corporate applications. So this is kind of the way architecture is moving, we think, for the control center. Some of the more advanced utilities in the world are certainly moving in this direction. Next slide, please. On visualization trends for the future, we want to do, I guess, 3 things shown at the top: Converge, Standardize, and Modernize. What do we mean by Converge, Standardize, and Modernize? Well, taking the first one, converging means to have a very similar visual styling for all of your applications in your control center. So I haven't seen the PLN system, but I'm reasonably sure it will have, black background, colored lines, red and green indications for on-off statuses, for example. Lots of color. So this is standard in control centers now. But your WAM system might be designed a little bit differently. It could have green and red color used differently, or it could have a different way to navigate around the application. What we want to propose with visualization is to converge these. So the look and feel is the same in your EMS as it is in your SCADA system, as it is in your DSA system, your OPF, your market management system, your WAMs. So if you have a color, for example, red is priority 1 color. If you see red in your EMS, that's danger. That means get somebody to site to fix something. If you see it in a WAM system, that means that's danger. There's an oscillation happening on your system. I need to dispatch on the system to fix. So keep a consistent visual styling across all of the applications in the control center, so that the operator doesn't have to look at different screens and try and interpret what it is they're looking at. What does green mean? What does yellow mean? What does blue mean? This is a bad practice. Standardize your colors and keep them across all applications. What we mean then modernize. So modernize, we mean by try to use color more sparingly on your system. So only use color to distract the operator, to say, hey, over here, we've got a problem on your system. There's a red flashing light. Come here and address it. So color shouldn't be scattered all over all of your displays. You should use neutral backgrounds, neutral colors, and then only use colors to show there's a problem on your system. You can see that in the bottom right-hand corner. It's a good example. Grayscale, and then yellow for an overload, and red for an outage on a line. So the operator sees immediately here, there's a problem with this power station on this system, right? Here's an example of a video wall in the same situation. So don't overuse color, only use it for abnormal indications. Next slide. Quickly wrap up. What we're seeing for hardware design best practice is a move, slow move. It's not quite there yet, but having these personalized video walls. So you can see here, here's a desk with 4 desk monitors on screen, and then a video wall that's personal to the operator that has all of their key information for their role. So if this person is doing dispatching on the grid, they will have all their dispatching information up here. Very close to them, they can see it. They're not looking far away. The graphics aren't small. They can interact with this video wall, so they can pull and push information to it and tweak it as needed. So it moves and it's ergonomically viable, right? There's not loads of screens in a horseshoe. It's like, it's just in front of the operator. They can just see and look up and they can interact with it easily. Visually closer, interchangeable information. So you can move corporate information, application information, and control center onto this. You can create dashboards, define KPIs, and then there's a single integrated interface. So there's only one keyboard, one interface that connects with all of the screens on your desk. You don't have 4 or 5 keyboards that are controlling different screens. Everything is integrated into a seamless application. Paper-free, uncluttered, sit-stand desks, and integrated telephone communications also in one application, so you don't have multiple phones. So that's the trend we're seeing on hardware and ergonomics. And then finally on decision support, the last slide, I think. Yeah, this is kind of associated with automation. So we need to embrace automation for the future control center, because human operators are not going to be able to control everything on the system. They need to be able to focus on the areas that they need to focus on, and let things that are manual and menial in nature to be carried out by automation scripts running in the background, okay? So operators should be really trained to embrace this automation, should be trained to detect if automation is not working, and to intervene, to then manually control the system, but not be sitting there doing manual reporting. An example of this would be reporting of a fault on the system. Operators shouldn't have to be typing out this happened, this happened, this happened at this time. This is all in the system, in the databases. It can be automatically developed. So in the decision ladder, which is here, move the tasks that are down here to automation, and the things that are at the top are where the operator's focus should be. Also creation, like I said, of an operations readiness center, shadow control center, training center, and user acceptance test center that's in parallel with your control room. That's it, I think. Or is there another slide? Yeah, thank you. Yeah, so that's it. Quick whistle stop. Sorry if I took too long, but I'm happy to take any Q&A. If you want to add them to the box, I'll take them. Or my email address is available, akelly@epri.com, if you have any questions on this. Thanks for the opportunity to speak, and talk to you soon.
Thank you so much, Adrian. That was a really interesting presentation. And with that, as he said, a reminder, please send in your questions to our chat and Q&A. I see some are already coming in, but we'll hand it off to Hongmin Zhang from NREL. Take it away, Hongmin.
Can you hear me?
Yep, I can hear you.
Okay, great. Yeah. Hey, everyone. So good evening or good morning, depending on your location. So thank you for joining this seminar session. I want to take a few minutes to go over a little bit observation and also some work and our plan from NREL perspective, how to support renewable generation operation. So next page. So I want to cover 3, just share a little bit, the current operating time. So we see, the growing with green energy, and also touch base what's kind of the key challenge to keep the control room up to the the new, how to say, the changing factor. Then they share some of our work and vision. Next page. Here I want to, using some, WEC, the CAISO, and the ERCA, the ERA, some plots to show what's the current, the operating time. So you can see from on the right side, you can see on the top, this is a project. This is a project in the solar, the rooftop. This is a DER type, kind of the resource. And you can see the increase, consistently. And based on the WEC and report and the CAISO report, we can see in next 10 years, those number could be double. And on the bottom, you can see right now for the DR site, those kind of residential type solar generation and dominate the change. I didn't put the slide for the utility scale. Utility scale right now, the solar in the Western connection was about I think 20 gigawatt, and it could be 80% of the double in next 10 years. And then the wind generation is 25 gigawatt and could increase another 60-80%. So you can see the overall those renewable generations increase fast in the Western connection. Next one. Oh, sorry, wait a second. Go back. Yeah, I want to point out, everybody familiar with this kind of the middle, on the left middle, the plot, people call it dark curve. Really, this is showing the renewable generation, including, utility scale and rooftop, those type can change the system load curve dramatically. The bigger question is, the one thing is, how to, keep those ramping power during those sunset time. But in the meantime, if there's a weather change during the day, and that way, there's a lot of load changing beyond a normal pattern. How to handle that? I think that's a challenge for the control room. Next one, please. So here's about a wing. So again, wing, I think the ERCOT is installed more wing in US system. So basically, right now, wing is already second largest installed capacity. For the Western connection, wing also is growing fast. At this point, close to 10%. This will be the capacity will be grow from the 25 gigawatt to around 40 gigawatt. That's based on the WEC report. We will see the traditional units like the fossil fuel and the coal, the natural gas, and the nuclear. All those together maybe are still around 50% for the next 10 years. But the renewable, the install capacity will more or less double. Next one. So here's a challenge we see. Before I joined NREL, I worked in the industry in a different control center for about 13 years. Basically, you can see that right now the EMS has a lot of advanced application, and beyond the inside, you can see that there's a core applications, estimation, analysis, and study tool. All those is support the control room function. And then most control room, every few years add a new application and transmissibility, water stability, and cybersecurity. All those help. But in the meantime, so those information, if you look at those together, I say the Andrew's display show more than 20 screen in front of the single operator. So those is a challenge for operators, the information overload. In a typical day, because a lot of the everything's under control, everything is green, operator may not see that pressure too much. But when things are going abnormal, all those information coming together, it's hard to make the actionable or the timely decision. That's the kind of challenge we see from the operator perspective. Next one. And here you can see on the top, so the industry add more in the renewable, variable renewable and manage application into the control room. So including the forecast of the renewable, the availability, and also the schedule, and also the trying to model uncertainty. So those is a kind of a lot of good effort. So I think that I just use example on the left. The NREL has those renewable, kind of the potential, renewable capacity potential, those two, and to manage wind and solar, and help industry. So there's a lot of similar effort, but the challenge is how to make those variable, energy information into the control room dispatch, timely, effectively. That's still it's to be resolved. Next one. So a few DOE's project support, at NREL, we try to kind of incorporate research application with control room application. This is a way we're trying to think could help industry to solve some challenge we just talked about early. So really, this tool is we leverage the control room, the similar production grade those software, the vendor, the DTS training simulator as a base. Then we have those transient stability and other to integrated. This is kind of just make sure that the functionality on the base is lined up with control. Then on the left, you can see we add those weather events and the natural gas and the information. And that natural gas is, everybody knows that's in a lot of the industry, the interconnection is 50% or 40% natural gas. Natural gas, the units is many units may be supplied by a single compression station or the pipeline. If that get an issue, and then it's not the MS2, MS3, it's the MS-K. The K could be over 20. In that case, what's the kind of the situation for the operator? So those is we want to bring this into the control platform, and for the MS-K simulation. Again, we can use those easy way to export the EMS snapshot to the DTS environment. Then we can run those MS-K in the time series mode, and also in acceleration mode. That we can understand what's the worst scenario and for the next few hours or even days. And another big part we did is we know there's a lot of good work on the EMS side, a lot of good work on the planning side, using planning model. But the connection, there's some disconnection. A lot of the planning tool is based on the purely base case, and then the EMS is all real time tool. So we build that path. We can convert the SEK solution to update planning base case. That way, the topology and overall situation is very close. That ensure the planning software, the analytics can still using the near real-time data to do the additional assessment. Next one. Yeah, here is we are going to move on. So really, we see right now the EMS, DMS is operating in the way you designed for a while, and really we see because of DER and those increase and those is make the control center connections to a new phase. How that means the DMS, the DER, those aggregate impact could make the bigger driver for the EMS control action. But at this point, EMS don't have the good idea. One example, if there's a bigger the fault on the EMS, the big bound system, how much rooftop this DER device could be disconnected, the relay tripped. So those is we can simulate very well, but it's those information not coming to the control room yet. How to get those information, because DER simulation time consuming, but how to get those aggregate accurate information back to the control room, and then the help the operator to know what's the system change going forward. All those we trying to leverage the new technology, and we list the few things here, and we trying to get leverage those modeling based tool, But meantime, using data-driven, those way we can give a lot of the agent. Those agent will manage a lot of calculation online. We envision that the system, the system operator that's still as it is for now, but there's the shadow system will do a lot of those calculation coordination and bring back those aggregated information back to the operator. So that's the kind of we are working on, and I hope we can collaborate with the industry and a partner, so we can find the practical user case. Then we can really apply those technology to help get everybody ready for the high level the renewable energy operation. Thank you. That's all.
Thank you, Hong-Min. That was very interesting. And so I think we are at the top of the hour, and we'll have about 15 minutes for Q&A. We already saw a number of questions come in, and we'll go ahead and hop on video as well. Hi, everyone. Sadie, I think we can kind of tag team moderating it. We have some questions on chat. We have some questions on Q&A. So I think I'll start with one of our first questions, which is for Pak Haryadi. So one of the first questions is, so if you need one, how do they define their subsystems with respect to getting data forecasts and integrating with weather? Or what is the geographic or topological resolution? So I think that's to Mr. Haryadi, if you want to hop on and answer that.
I answer now, Isabel?
Yep, hi.
Okay. In the case of how we will integrate this weather forecast to our system is until now we still don't have enough information or about the plan. Yeah, how we will integrate this, because now in our system we just only have some weather data from meteorological. We don't have any weather measurement unit that connected directly to our system. Now our weather information from meteorological agency is just only the forecast for rain and maybe some information, not detailed information. We still have some problem to forecast how this connected to our load now. We try to forecast the impact of this to our load, but still don't have a good method for this forecasting method. Yeah, and then we try to discuss with the meteorological one and also some institution in our university how we will plan this data. This will be very challenging if the renewable comes to our system, because we will also have some countermeasure, especially for balancing power. Now we will have around 125 PV voltage in the near future. They're built in Cirata power plant, is for a hydro power plant. Maybe this not so big, but this will be impact in our forecasting. If another renewables comes to our system and we still don't have any forecasting, good forecasting for the weather impact in our load and also our energy forecast for these renewables. We need maybe some benchmark from another utility, how they connected this weather forecast to the system. That's my opinion for this.
All right, thank you. Great. So I think this is a question for Adrian Kelly. So regarding alarm management, is it purely based on rules or templates, or is there any sort of AI or machine learning crunching behind it? So I think that is for you, Adrian. Adrian, I'm not sure if you're speaking. I don't think we can hear you at the moment. Okay, maybe we'll come back to that one. Maybe Adrian's having a little bit of, oh, he's trying to unmute. Oh, WebEx is broken. Well, that's pretty par for the course sometimes with WebEx. Okay, well, we'll give you a second if you're able to unmute. In the meantime, we can, there's a question for Hongmin. So what is the status of the RTAG project? Is it already available or under development? So I think that is for Hongmin if you want to answer that question about the RTAG project.
Thank you. Basically, can you hear me?
Yep, we can hear you.
Yeah, basically that's a part of our effort to support the DOE NARM project. We able to install all the necessary software and to run the Western connection wide simulation, and we can simulate the normal, the high summer, on peak and winter, and high renewable. So that's right at this point. The platform is functional with a Western connection model. That's a whole Western connection model. We also looking for the partner, so that way we can keep the model up to date and support the resilience study. Yeah, let me know if you need any additional information. Right now we are trying to expand. So we're trying to expand the model and also trying to expand the capability. The capability is really, we want to make sure the control room can have the way to grab the key information, the aggregate information from the DER, the DMS, those systems. That way we can manage those renewable changing due to the weather, extreme weather. Thanks.
Great, thank you. So I have another one for Pakaryadi. So the question is, given that PLN is a vertically integrated and government-owned utility, how do you expect that changes in regulation will be implemented and enforced on generation plants to make them adopt all the changes and equipment upgrades needed to be integrated into your new system? So that one is for Pakaryadi, if you would like to address that question.
I try to answer the question that's until now the system, especially for transaction model in our system, based on single buyer system, that PLN is become a single buyer, and all of the participant of generation, it must be sell the power to a single buyer, and the single buyer will sell the power to the distribution agency. Start from now, there is some competition in our transaction model, but still in generation 1. The problem is now also happen in how we will guarantee the investment of the independent power producer. Now the single buyer is be the one that that guarantee this investment. Based on this, the real competition, the real bidding process, the transaction model is not good for PLN also. And now some initiative has been started how we will manage this in the near future. Maybe in the near future, especially if something happen especially when the renewable comes, it must be there is some need in balancing power and also the backup power. If this cannot be answered or cannot be fulfilled by the system, it will be PLN will be preparing this balancing power and also the backup power. This means there is another burden for PLN for this. I think the new transaction model may be based on the market model, but maybe there is not fully like American system or a European system that's very liberal system. Maybe in our system still there is some country intervention in this transaction model, but we need this new concept of this single buyer system. Based on this, we need the new control center also can answer this challenge. And we need a discussion also with the government how we will make some transition between this single buyer system with the new system for transaction of the generation power. That's all my answer, Isabel.
Great, thank you. So it looks like we got Adrian back. So welcome back, Adrian. It wouldn't be a WebEx event if we didn't have at least one hiccup. So I'm going to come back to you with that same question about alarm management and whether it's based purely on rules and templates or if there's any sort of artificial intelligence or machine learning behind it. So hopefully you can be unmuted.
It's a great question. It's a great question, one we get asked a lot. So I would answer it in a couple of ways. So for utility companies that have existing systems that they're not going to change with multi-million points in their database that are really suboptimally defined, it's a very difficult process to go through what I was talking about, that documentation, rationalization, structuring your alarms, your alarm model. If you've got tens of millions of alarms, it can take 2-3 years. Believe me, I'm in the middle of a couple of them with big utilities in the US. It's very complex and difficult. So in those cases, they try to speed it up with some pattern recognition and root cause detection. And we're working on that in EPRI as well on specific tools for that. So if it's too difficult to rationalize, then try to develop smart applications. For PLN, you guys who are ripping up the your existing system, believe me, it's much easier to structure your data with a rules-based system like what was suggested at the early stage. So put your alarm data, match it up to your model. So if you've got 15 alarms on breakers, match that to your network model so that if the alpha station has a low voltage, you can match that to your alpha station alarms pretty easily, and then you can really easily build in pattern recognition with the structured when your data is structured. So so I hope that answers the question. There's two approaches. Long-term documentation rationalization projects are the way to go to put your data in the best position. But if you need to get something there quicker, you can develop algorithms. You can develop some algorithms, but they are early stage. I wouldn't claim that these algorithms are really effective at smart alarming or root cause analysis, that type of thing. So DNR is the way to go, I would say, Isabel.
Oh, Isabel, I think maybe you're muted unless it's just me.
I was muted. Okay, thank you. So sorry, everyone. I was going to say we have time for one more question. So we'll end with this. I think this is for Adrian. Are there any available case studies or examples of control centers that presently utilize operation readiness centers that utilize tools offline and aren't integrated to the control center tools? I think that one's for you, Adrian.
Yeah. Good question again. Good question again. I would say I tried to answer this here. The thing to remember is the operations readiness center would be put into would be within the security perimeter of the control center. So we're not proposing that this is a separate center, you know, in a different office space. So it's within the cyber and physical security perimeter. That's where it should be located. That's the first thing. So, and then the second thing is control is not carried out on the system, is not carried out from the operations readiness center. It's basically making the DTS more useful. At the moment, DTSs are just like they're simulators with images of the system. What we want to do is make that into a real-time shadow operation. So it's exact replica of the system, has some exact replica of your market system, of your weather forecasting system, exactly replicated in this readiness center. And then if there's an upgrade to your EMS coming along, it isn't crash landed into your control center and has to be tested in real time. It can be tested in this shadow control center offline. Operators can interact with it and play with it and suggest some changes and all of that. So it's kind of supposed to be a shadow. Are there case studies? No, but we're working with two and maybe three that are actively developing these or developing plans to get these off the ground.
Great, thank you. So I think that is all the time we have for Q&A. I know we didn't get to everyone's questions, and there were some really great questions. Thank you everyone for participating and for engaging with us this morning. Absolutely, thank you so much to Adrian, to Hongmin, to Pat Karyadi, and to your organizations for working and collaborating with the G-PST. So if we didn't get to your question, we will do our best to follow up with you guys, answer them individually. Again, we will have the recording as well as the deck available on the Global Power System Transformation Consortium website here in the next few days. So please be on the lookout for that. As Sadie mentioned in the beginning of the webinar, please feel free to visit the G-PST website, open up our Get Involved page, sign up for our mailing list, and just get involved with us, however you'd like to. So I think with that, I'll go ahead and conclude the webinar. So thank you again, everyone, and have a great day. All right, bye, folks.
Thank you.
Thank you,
Thanks,
Isabel.
everyone. Bye.